All right, so I figured it'd be a good idea to do a regression example. So this one says 2007, there were 19,000 people in Davison. In 2010, there were 22,500 people. I just made those numbers up. I don't think those are accurate, but just for the sake of the problem. So create the exponential regression equation. When we did this, remember, one of the big keys, let me clear out what I've got, is you don't want to put this year in because that will actually kind of confuses the calculator. It's too big. It makes it really hard for the calculator to figure things out. So always call the starting year year zero, and then the next year, however many years afterwards it would be. If you don't do that, we'll check it out in the end, but usually it won't do the calculation for you, or it makes it really confusing. So remember, always treat this as year zero. So the starting year, year zero. From here, we should be able just to go stat, over to calc, and pick exponential regression. And if you're using the calculator that I have pinned to the classroom, it's pretty straightforward, kind of the same thing, but make sure you do pick the one that it says on there, the exponential regression one. All right, so we run that and gives us a nice equation. So this would be y equals starting value of 19,000, which makes complete sense, and 1.0, and I think I'll just round this to, let's see, that would round up, so 1.058, we'll call it that. All right, perfect. At this point, I can now answer all the questions. How many will there be in 2020? So that's going to be 13 years later. So I can go ahead and put my equation in. And I can see what we're going to have in 2020. Definitely got to do some scrolling here. But one thing this will show you is it should match up pretty much exactly what's on here. So the first starting year, 19,000. Yep. 3 years later, 22,501. And the only reason it's slightly off is because we did round this number. So, obviously expect that it shouldn't be off by more than maybe 1, maybe 2, depending on rounding and things like that. So we want to go 13 years later to get 39,543, which is actually kind of interesting because this sort of answers the next question. It says, when will the population double? So we're looking for the first time it hits 38,000. That's actually also the same year. That is the year 2020. So between 2019 and 2020, but either way, if you want to kind of say between them, that's fine too. So yeah, perfect. Everything looks good. Everything makes sense there. Just to see, let's go ahead and let's say you made the mistake of putting these years in. I don't think it'll work. It usually doesn't, but sometimes it will. It all depends on how high or how low the numbers are. Yeah, so you get really weird numbers because this extrapolates back to year zero, like from 2007 going all the way back to like the year zero, like 080 or whatever. So yeah, you'll notice the growth rate is correct, but the starting value, very confusing. So if you did this method, just remember that's your starting value, but it does preserve the same correct growth rate. So that is another way to do it, but honestly, just do it the right way, which is putting in 0 and 3 for those values. Alrighty, try some of those out today and be ready for a quiz soon.